Okay, we're starting. This is webinar 41 about object-oriented programming. And the subject today is going to be return statements. I'm not sure we're going to fill the entire hour because the subject is pretty short, I think, but I will try to say as much as I can. I was trying to prepare for it, and I read my blog post of 3 years old. I wrote that thing 3 years ago where I said that return statements are just in general a bad idea for object-oriented programming because multiple return statements are a bad idea. Not in general return statements, but many of them inside one method. That's not a great idea. And then I gave my reason there, and I provided a link to the discussion on Stack Overflow, and I clicked that link today again, and there are so many answers there. There are a lot of discussion, which I found quite interesting. I reread many of the answers today again, even though I read it before, and they are saying that this whole idea about having just one return statement in the method came to us from languages like assembly and Fortran, I don't know, 30 years ago, and the idea was called single entry, single exit, and it was introduced by Dijkstra, quite famous scientist, who actually claimed, among other things he did, but he claimed that go-to statement was a bad idea, and that was long before I started programming. That was many years ago. So they are saying in this page that having multiple return statements and multiple entry points, which we don't have now in our languages at all. So it's not possible to enter a function at a few different places, which was possible in Fortran, which is a surprise for me. So it was possible. In assembly, it's not a surprise. You can jump to any instruction inside the routine or subroutine, and then it will just, continue flowing, and the execution will just go from there. So you don't have specific entry point. Well, you have an entry point, but it's only a formality. But technically, you can jump to any address. In Fortran, they made it possible as well. Now we don't have that in Java, in C++, in any modern languages which would allow you to jump into the function, not to the beginning of it, but to the right into the middle of it. That would be pretty weird, to be honest. But that existed. So Dijkstra suggested in his book that this any subroutine at that time had to have a single entry point and single exit point, and there was some discussion about that, why it's better. Basically, the main reason was that it's just easier to maintain the code, easier to understand the code if if it has just one entry point and one exit point. It's all about maintainability in this question. So of course, the functionality will work, and I will demonstrate you a few examples from my own code today, and to show you that that functionality works no matter what, whether you have these return statements, many of them, or you don't have them. But it's all about maintainability. So how do you make your code more, easier to understand? How do you make it less complex and easier to modify in the future, with multiple return statements or without them? Let's take a look at them at a simple class. Forget about object-oriented philosophy for some time, because my article on the blog was focused very specifically on object-oriented idea, and there in that article I said that in an ideal object-oriented world we need to have just classes and no statements and not even method calls. That was my utopian idea, and in order to avoid procedural programming. So as far as I understand the perfect object-oriented philosophy, it has to have just a large composition of objects, and then at the final point somewhere has to be one final call to give life to all of that objects. So if you look at that code here, then for example this part, let's remove this for now, let's comment it. So this part would be, it's Ruby, so it will be if new and new this is how I would do it in a more object-oriented way. So I would not have this if then else. I would make an object called if, which you see never called. So we never ask, we don't ask that object to execute right now. We don't give control to that object. We just instantiate it. We just make an instance of it, and it encapsulates a few other objects. This one is a condition. This one is what we need to return if the condition is positive, and that one what we need to return if the condition is negative. But the word return does not exist here, so we don't return that stuff. We just make that object if of class if become that thing or become that thing depending on what that thing is. You see? So we're not returning, we just created something which may behave in different way depending of what's inside. But we never asked that stuff to actually run and execute and, for example, validate that expression. So we never gave control to that structure, to that entity we just created. And that's the beauty of it. The lazy execution, let's put it this way. It's delayed execution or whatever. But the beauty of it is that, at the moment of constructing an object, instantiating it, we don't know what's going to happen at the time of execution, at the runtime. This is declarative approach. It's not imperative where we actually, this is imperative. This code is imperative, you see? Seconds equals to time now minus time before. So that's exactly imperative instruction. We're just instructing the code, the Ruby runtime machine to get the current time and deduct some time from the attribute time. So this operation minus will execute exactly here right now, and computer resources will be taken exactly here. The same will happen here. So we call this private method text, which will do something and save it into the variable txt. That's pure imperative code. This is not far away from assembly, from Fortran, from all the languages which we had 30 years ago. Well, you had. I didn't have them. Well, I was too young. But some of you may have had them a long time ago. We still have that stuff here. It's imperative. Some people say that it's better to think that way, that we are, as people, we think in an imperative way, so it's easier for us to understand this code comparing to that one. Because look, it's clear that at line 43 we calculate the time difference. At line 44 we build the text. And then at line 47/51 we do something, we create some object which we don't know how will it exactly behave. We don't get any result. We cannot debug it. So if you put this structure, I don't know, for example, we say this is an object equals to something, and then we return that object, and then here I want to debug that stuff, and I say object. That's how you debug in Ruby. For example, puts object or p, just p object. Then it will print something which is not the result of this execution. It's going to be some information about that object, like the object ID or what's encapsulated or something like that, but it's not going to be the result of the execution. To execute that, we will need to do something like I don't know, let's say, in this case it's, for example, like that, so convert it to text, to string. And then in that case, the object will run, will do something, will spend CPU time, will spend resources, computational power, and then will return something. So it is declarative because we declare an object, but we never execute it. Somebody who is calling us, who is staying outside of this method, who is the client, so that guy will potentially, maybe sometimes, we don't even know when, will call this method to s, or maybe some other method, maybe something else, and that will lead to some actual code execution. So I'm in favor of the second approach. I believe that this code is better. Maybe on small primitive constructs, on primitive things like if, and, else. Maybe I also think that if then else is easier, because I'm also a procedural programmer by my history. So for me this thing also looks, well, a little bit too much. But in my book, in Elegant Objects, I'm saying that no, it's not too much. This is exactly how it should be, so just do it. I understand that none of you, or maybe very few of you, maybe just for an experiment will do that. But in real programming, in real world, you're not going to do that nonsense. You will just write if, then, else. But that's because we're trained to be procedural guys. Because if you show that to some functional programmer, then they will tell you that no, it's perfectly all right. They write code like this. They would write it in Lisp or Clojure or whatever. They will write it if, and then and something, and then if it works, then it's going to be some rainbow, and if it doesn't work, then it's going to be some txt. So they write it exactly like that. Any functional programmer will tell you, like, yeah, this is how we do this forking, the logical forking. But for us, object-oriented programmers, we for some reason are more procedural, way more procedural than functional. So that's the philosophy. So I believe that is better, conceptually, and if you, in general, if you think why return statements, and of course, let me get back to the primary subject today. We're talking about return statements. So if you define your all the code inside your method, you define as a structure, like here, as something which you construct, as you instantiate and return, then basically there is no place for the return statement. You cannot return half of the object. You either return the whole thing, boom, the whole object goes out, or nothing goes out. I mean, there's no other option. If we agree that there is no place for anything else inside the method, so something like that should stay inside, and no other lines may show up. Not before, not after. It has to be like that always. In that case, you will not have any questions about return statements. You will have no return statement at all. So basically, my article says that return statements are bad, multiple return statements are bad, which means that there is only place for one return statement, which means we don't need no return statements. Because if there's only one and we don't use many of them, meaning that we don't need any of them. In Java, you would have to say return. In Ruby, you also can do return, but there you see there's a highlighted because we don't need that. So RubyMine is telling me that I need to remove it. So that's the philosophy. But practically, if you look at the practical situation, and let's get to it, let's forget about the philosophy and talk more about the practical things. So look at this method below. It has 4 return statements, and then one line goes also the return. So I can put return here as well. So there are 5 return statements. 1, 2, 3, 4, 5. And what it does, you can see, is this is the class that calculates the age, which is the distance of time between the current time and some time which is encapsulated. So I'm doing this. So if seconds is less than 1, then I return something. And then I continue. So if seconds is less than 1, so it's bigger, then I return this. If seconds is less than 60, then I return the amount of seconds. If seconds is less than an hour, then I return minutes, and otherwise I return hours. And then all of a sudden, I today realized when I was preparing for this webinar, I was searching through this source code, which is a Zolt cryptocurrency source code, which we're developing right now. And I found another class which calculates the size. That one calculates the time, so it converts the time difference into seconds, milliseconds, minutes, and hours. And this one takes bytes and returns you kilobytes, megabytes, gigabytes, whatever. And here, this is again my code. So that was my code. I wrote it, I don't know, maybe a few months ago. And this is my code. I also wrote it, which is written completely different, as you can see, ironically. And here, there's only one return statement. Because this stuff, there are no return statements. It goes like this. You can basically assign it to, so it goes like this. So return statement has to stay, no, it's not like that. You can say, for example, yeah, and then you return it. So basically in Ruby, you cannot do it in Java, but in Ruby it's possible. So you say if, else, and the result of this entire statement will be saved into the variable X. But you can skip that because, it's the single variable and there's a single return. So you go like this, which means you return the whole thing out. But you don't do it step by step. You don't do it in an imperative way. You do it in more functional way. Let's put it this way. So this code is obviously imperative. This one is obviously functional. So which one is better? I don't know, to be honest. Because I wrote two pieces, and for some reason here, when I was writing this, I was thinking that this is the better way. This is a better way. Here, I thought that this is a better way. But now when I look at that code, you tell me which one is better, but for me this one looks a little bit better. I'm not sure about the performance. I think performance-wise it will be almost exactly the same, because we'll also do the if, and if sort of the checks will go into this exactly the same order. But this code looks to me, nicer. This one is more, the logic here, when I look at it, is kind of hidden from me. So I cannot tell, by looking at it for a few seconds, I cannot tell exactly what's going on. So I need to investigate a little bit. I need to investigate the logic that those return statements are actually attempting to, calculate something similar every time, and just return it for a different situation. So I cannot connect these four guys together. They don't look to me like they have to stay together. They look like there are some, as they call it, guard clauses. So they're guarding my real line here. So it seems that this is the real line, and those four are not real lines, but they are just trying to escape the method. So they're not really returning something valuable, but they're escaping for some exceptional situation. That's what it looks to me now. But this one looks like this is pretty logical forking into 5 lines. So 1, 2, 3, 4, 5. So there are 5 directions, and we are forking into 5 ways. And they're all part of the same logic. It's the same algorithm. Here, I don't know whether it's the same algorithm or not. It's like, can I add something here? Can I, add some extra line here or not? I'm not sure. I need to investigate. I need to find out. So maybe that's an example which will demonstrate you that return statements are less maintainable. And I will, I don't need to show you how to rewrite that code. You can do it. Well, you understand how to refactor that to make it more, to get rid of all these return statements. And now let me show you a larger example where also in the same code base. So look at this stuff. There's one method called push1, and it has 3 return statements. Again, it's my code. As you can see, I'm not always proud of my code. So here goes one return statement, then another return statement, and of course in the end, the final return statement. The problem with these, let's call them exceptional return statements or escaping return statements. The problem is that the biggest, I think, problem, if we go outside of simple examples like this one, if we go for something more complex, then every time we jump out of the method with something which we don't have at the end, then we need to remember that if here, for example, let's say so that will be the right code. Okay, so we return v. As I said, like in Ruby, you can just skip the return statement. The final calculated something will be returned as a result of the method. But now we have obviously 3 lines. There's 3 return statements: 1, 2, and 3. So we need to remember that if we want to do something with this final value we return, then we will have to do it at 3 places. So let's say I want to, simple example, I want to log what I'm returning. I want to do a primitive logging. Okay, let's do not primitive, but the proper logging. We have the log object inside. So I'm saying the v is v. That's my log line. Boom, I'm happy. I'm looking at the final line. I'm adding this return statement, this logging line, and I run the code. And I don't log this and I don't log that because they escape earlier. Or for example, I want to say, okay, v is v, and if v is less than 0, raise an exception. V can be negative. Boom. That's great. That's a great, validation before we actually jump out of the method. And then here I do -1 for some reason in a few months. And it will go well. The -1 will be returned because this control statement doesn't know anything about that. Because we jump out from 3 different places. And we need to validate at 3 different places as well. That's the problem. That's the main key maintainability issue with return statements. If we have many of them. So the right way would be to get rid of them. How do you get rid of them? You introduce new methods. Simple as that. Well, ideally you go with new objects. Like I'm a big fan of multiple small objects. The more small objects you have, the better. In general, that's a general rule of thumb which I preach for years, that more objects, more classes is better than less. So if you can extract some functionality into a new class, do it. If you can introduce a new class which does small things, small operations, but you can actually isolate them into a new class, you have to do that. That's absolutely absolute. That will do good for you in most cases. In most cases, I was just checking your question. So how do we change that code? We have 3 lines. The code looks okay. Let's find out what's going on. So there's push 1. I'm saying if some option. Okay, I'm saying debug and ignore. So I don't want to push anything. I want to ignore. So I'm not going to run this whole thing. I'm just going to exit here. So this is basically the guard clause. I think I pronounced it correctly. Yeah, this way. So that's the guard clause. So the clause which protects the entire code from everything. I think this name was introduced by Martin Fowler, if I'm not mistaken, and he suggested that is a good idea to have these guard clauses. That instead of instead of doing this, which would be, the correct way, you see, I'm not using return anymore. I'm just returning from the if statement and then from here. So that's good. But Martin Fowler said, no, it's not good because, that's too much indentation. Because you see, we just indented that code two more spaces right. Because before that, it was, shifted left. So we indented right, and let's get rid of this return statement. And you will see that the problem is even bigger. So that will be, that will be the perfect code, just one single return statement. But Mr. Fowler said that that's wrong. How about we get rid of this indentation and introduce guard clauses? I respectfully disagree. Because I think the right way is to introduce a new method instead of making the existing method more complex by return statements, which, as I explained, only makes the code less maintainable. How about we introduce a new method? So you want this to be an execution. How about we copy this baby here and we call it push1 for sure. I don't know, something like that. And then we get rid of the indentation. Push1 forcefully. So we push it no matter what. And then we do so that's how you refactor it, Mr. Fowler. Not by guard clauses, but by introducing a new method which helps us, first of all makes the code shorter. You see now this code is shorter and better, easier to understand, and we can get rid of this one as well. Let's copy this baby and let's get rid of this one. I'm not sure it will work like it is now because I'm not most probably sending the parameters correctly, but so here I'm saying it's not push, but what I'm doing now is let's call it push HTTP. So now we have three methods. Look, the first one, the second one, and the third one. And we have one single return statement in each one of them. Did we actually improve the code? Yes, we did. We got rid of multiple return statements? Yes, we did. Did we introduce any guard clauses? No, we didn't. And ideally, of course, like I said, in a perfect world, you would actually try to move that stuff into separate classes because this is private, you see? So all this stuff is private. This is private method, this is private method, this is private method. And as I said in some articles, I believe in my blog, is that any private method is an indicator of the complexity of the class, which is too high. So if your class has something in private, that means that this private stuff can and should be extracted and implemented as a separate class. So ideally, in an ideal object-oriented world, all your classes must not have any private methods. I think so. I would actually say, maybe it's too extreme, but I would say that private methods are a bad idea in object-oriented programming in general. So without them, I think the code would look better, because if you prohibit private methods, then programmers will at the same time will remember that making everything public is not a good idea as well. So you design your class, you define public methods, you make sure they extend your types, they implement your types, so you don't, as you know, you don't introduce any public methods unless they are coming from the types or interfaces or protocols your class is actually implementing. So you make them, and then you need some more functionality, you need some more features which you don't know where to place because you don't want to make them public, you don't want to make them visible for somebody else, but at the same time you need them inside the class. So what do? You don't do private, you go for a new class. You move that functionality outside, you make it a reusable feature, you make it a reusable library, classes, whatever, something reusable outside, and then you call that stuff, you use it from your class. That will be ideal. So what we're looking at right now here, it's not a good design. It's far from being perfect. That's why this library, this product is experimental. It's not ideal, it's not perfect. Also because, the code looks, as you can see, too complex. But you see, after a very simple refactoring, which I just did, we made it better. And why did I start the refactoring? Because I knew that multiple return statements is a problem, is a bad idea. So if you put that rule into your heads, and you will just know that no matter what, you're not going to have multiple return statements, then you inevitably will refactor the code and will make it shorter. So that's basically what I wanted to tell you, to show you. Let me check your questions. Maybe you have something interesting to ask me. Question number 1, can you show an example of if class at the end? I don't get how would you write that class without logic in constructor. Here then. So let's say this is class if new. Let's make it simple. If new 1 is more than 2, then return hello, otherwise return bye. Okay, so now we need to implement that class. So how I would do that? Okay, it's Ruby. Def initialize. So first we encapsulate the term. Then we encapsulate the positive return, and then the negative. First of all, I encapsulate it. Let's make it simple. Jesus Christ. This Ruby mine is killing me. That's why, someone asked the question before the webinar whether I like Sublime text or this Ruby mine, which I'm using for the last, I guess, 2 weeks or maybe 1 week. Well, to be honest, I do like Sublime text way more up to now, because maybe I'm not a good user, not a professional user of this Ruby mine, but it seems to me that it gives me too much hints and too many fancy features which I don't really need, and it's slower. So obviously Sublime text is extremely fast, it just flies. But Ruby mine, sometimes there are delays, sometimes all these fancy forms. For example, if I need to find something, look at this. Boom, boom. I don't know what this one is jumping out. This is the find form. See, it's too complex, it's too much for me. I would prefer something, simpler. Anyway, I'm not gonna not recommend it. And then the code. And then now we need to, first of all, you see there is no logic in the constructor. I just encapsulate. I don't need to run anything here. And then, since it's Ruby, of course in Java you're not gonna do that because you need to implement the class. And then in Ruby you can do that. You can do def method missing, I think. So there's possible to do something like that. So if the method is missing, if I call later that let's say I do this and then I say x to s, so this 2s will be directed here, and then here I'm gonna say if t, then I do p and then I don't know how to call it actually. Maybe send or whatever. I don't know how it works in Ruby, but this way. Otherwise, negative. Send, or I don't know. So I am intercepting the call, and then depending on this encapsulated logical variable, I just redirect it left or right. That's it. That's how I would do it. Let me check another question from you. Yeah, why do I need to require time in the size class? That's obviously a typo. Thank you for noticing. Next question. If you can hear the sound outside of me, there's salutes going on. It's a January the 2nd, and I am somewhere in the downtown, so people are still celebrating. Next one. I think H-class test method looks neater. H-class looks neater. This one. Well, for some of you, like I said, for me, I don't know, I wrote it. This is my code. So it looks like when I was writing it, it looked nicer to me. I thought that this is how it should be. Now I think that this one should be. So it's really a question of preference. But then I demonstrated you the larger example where obviously it was necessary to get rid of return statements. So which brings us back to this class and tells us that most likely here it's better as well to get rid of multiple return statements. Why something in single quotes and something in double quotes? It's from Ruby syntax. So in Ruby, in Ruby that's the way you work with strings. So sometimes you need double quotes, sometimes single quotes. Let me check another question. The webinar will be saved. Yeah, of course, it's recorded so you can watch it later. Compound names. It looks like that all push might go into a new class. Exactly, that was exactly my point. So all of these push methods, they can perfectly go into new class and stay there. Another question, in a perfect object-oriented world, is there any void method? It feels strange if an object returns something when it's supposed to print something, for example. Yes, I think in the perfect world, in the perfect object-oriented world, you may have methods which return void, but this void should be an object as well. I think so. Another suggestion, I am using Visual Studio Code with Ruby Solar Graph. I've never heard about that. I can try. We will have if-else forking eventually. Do you think switch statement is better? Yes, I think switch statement is better than multiple if-else. So that's a good suggestion as well. So here maybe it's better instead of this, instead of doing else if, do the switch. So that's case, bytes, and then you do when, like this. I believe that's the code. And then when, I'm not sure, else. Maybe that will work as well. When, else if, well, I'm more like classic guy, I don't know, but I usually prefer if then else versus case. Probably somewhere I saw some static analyzer telling me not to do that, not to use switch. Maybe in Java or in C++, I don't remember. And that's where I started to, to use if then else always. Another question. In Java, single return statement may force us to use non-final variables. Thinking about that. Single return statement may force us to use non-final variables. Well, I'm not sure I follow here. Well, anything can force us to use non-final variables. anything. Well, I'm in general, I'm in general completely against non-final variables. If the variable is assigned, you don't. No, wait a second. No, variable is no. I'm against the non-final arguments, but the variable can and must be non-final. I think so. Yeah, final variables. What's the point of having them? Variable is something which is changing its value inside the method. I'm lost. Anyway, about the void. Void object sounds interesting, but what would be the responsibility of void creature? Well, I think we have in Java this void object. So you can just create it, you make an instance of this class, void, but you can't do basically anything with that. You can only return it as a result. It implements some basic interfaces, and you can use it as a replacement maybe for nil, for null, something like that. I'm not completely sure. So I think we are going to finish. As I promised, it was going to be quite short because the subject is very limited, and it's a New Year, New Year holidays here. So thank you for attending. I hope it was useful for you. It is recorded. Please come back next month. It's going to be the first Wednesday, 11 in the morning Pacific time. And by the way, as you know, I started this daily videos. So I record every morning. I make very short videos about programming, about management, about all that stuff. And you can watch them every morning on my YouTube channel. So don't forget to subscribe. Stay tuned to the channel. See you next month. Bye bye.